we will continue our look at similar triangles today. All right, and so we're going to look at AA, similarity of triangles. So if you remember, we talked about congruence, right? We had some congruence shortcuts that we used. So we did like side, 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 angle, angle, side, angle, and all that good stuff. And now we're going to talk about similarity shortcuts, okay? So like pieces of information that we know, or the few pieces of information that we need to know in order to show that two triangles are similar, okay? So the first one we're going to talk about, one of the big ones here, is angle-angle similarity of triangles. And our central question is we want to know, how can you show that two triangles are in fact similar, okay? So we're going to skip this little explore here, okay? We're going to just jump into, let's see here, page 613, I guess. Okay, we're actually going to skip into that. All right. There's also a proof about proving angle triangle similarity. We're not going to worry about that either. I just want to jump into some actual some problems here. Okay. So applying angle similarity. All right. So we want to, in example 2 here, it says just find the indicated length if possible. Okay. So part A, it says we want to find BE. So if you look here, over here in our diagram, there's our diagram, and there's BE. That's the side that we want to find. All right. So we don't know what it is. We'll put a little X there. Okay. Now, it looks like these two triangles might be similar, but we're not sure. Right? We don't know for sure these triangles are similar. We are never told in the directions here, okay, that the triangles are similar. We're only told find the indicated length if possible. So it might not be possible, for example, if these two triangles aren't similar, we might not be able to do it. So let's see here. So the goal then is to look at this picture and see if we can find a pair of, or two pairs of congruent angles between these two triangles here. So can anyone raise their hand and tell me if are there any congruent angles here that we have? Yeah. Go ahead. So Tanner says angle C and angle E are congruent. So how do you know that's true? Very good. So you have parallel lines here crossed by this transversal, and that makes angle ACB and angle BED congruent because they're alternate interior. Okay. We're on page 613 there, Adam. Okay. So that's right. So that makes these two angles congruent. All right. So that's one pair of congruent angles, but that's not enough yet to say they're similar, right? So Evan, what do you say?
Angle ABC and angle EBD.
Very good. Okay. Thank you for using the 3-letter name there. Yep. Those two angles are congruent. And then do we have another pair here congruent? Yeah. So what's the other pair? Yeah, Melissa. Exactly right. Okay, now notice, did we need to say that last pair were congruent? We did not need to say those last pair were congruent, because all we need to show that two triangles are similar is we only need to show that two angles are congruent to two other angles. Okay, but here's the thing. If we know that two angles in one triangle are exactly the same as two angles in the other triangle, what do we know about the third angles? They have to be the same, right? If two angles from one triangle are congruent to two angles from another triangle, they have to be, the third angles then have to be the same as well. They must be, right? So, for example, if I have like a triangle that's got, let me just show you here as a quick example. So let's say I've got a little triangle. Oh, that's way too small, actually, because I can't even like write inside of it. All right. Say I got a triangle here, and let's say, I don't know, this is like 50-degree angle right there, and then a 40-degree angle. Okay. And then I'll draw like a bigger triangle, same kind of size and shape, and let's say again that's a 50-degree angle right there. Well, I already know that I got the two right angles, so those are congruent. I have the 50-degree angles, those are congruent. And then to figure out this missing angle, I could do 180 minus the 90 minus the 50. It's going to give me 40, and that's equal to the third angle right there. So basically, if we have two angles in one triangle, congruent to two angles in another triangle, then their third angles must also be congruent. Okay, because those angles have to add up to 180 in the first place. So that's the idea behind angle-angle similarity. Okay, these two triangles are going to be similar for sure, not necessarily congruent though. All right, so we want to find BE. So now that we know that these two triangles are similar, by the way, let's see here, let's name these triangles. So let's say triangle ABC is similar. Remember, the similarity symbol is just like the congruent sign without the equals, so just a little squiggle, that's it. Triangle ABC is similar to, and then how should I name this other triangle? Can I name this other triangle however I want? Like I called this first one ABC. Can I just call this other one whatever I want? So for example, could I call this other one BDE if I wanted to? Is that okay? So why can't we just name this thing however we want? What's the thing we got to look out for, Hunter?
Because like you have to name it EBD because like the same angles has to be together in the same line.
Right. So we established, for example, right? Melissa said that A and D were going to be congruent. And so that means that A and, oh, now did I just make a mistake here? I may have. Okay, so actually it's not going to be EBD. Got to be careful, sorry. It's going to be, so again, A is congruent to D. So that means the first letter here is A, the first letter here has to be D. Okay, and then B, well that's going to be matching to the B, and then E. Okay, so we have to name it in that order because angle A corresponds to angle D, angle B corresponds to angle B, and angle C corresponds to angle E. Okay, so that's why we have to be very careful how we name these things. Now, this is helpful. Now that we have the similarity statement, we also know which sides will correspond as well. So, for example, this X, that's a measurement of EB, right? Okay, what does EB correspond to in this other triangle here, Adam? Okay, it's the same as BC, right? So, what's the ratio that I can write there? I can write X over what?
Over BC.
Mm-hmm. So what's the BC's measure?
Oh, 54.
Yeah, 54. Yep. You could put the letters BC, but ultimately we need to put the number in there so we can start solving for it. Mm-hmm. And then Adam, can you give me another ratio that we could set that equal to then?
36 under 54.
Okay, good. Okay, yeah, I was gonna say yes, exactly right. The 54 is also from the big triangle, so it's got to go on top, just like the X was, and then 36 goes on the bottom. It corresponds to it. Okay. Adam maybe just eyeballed it to see that, but Adam can also confirm that he's right by looking here. BD was that side. BD is the first two letters, and that then corresponds to the AB there, and he was right. It was the 36 that matches with it. So he's right. Okay. And then Adam, how do we solve something like this? Cross multiply. That's right. Okay, so let's see here. We get 54 times 54, which is 2,916. And you can divide both sides by 36. So 2,916 divided by 36, 81. So BE is 81. Okay? It's just a matter of matching up those corresponding parts. And then cross multiplying and so on. Alright, questions on any of that? We're good? Alright, let's go to the next one here. So here we want to solve for RT in this picture. And again, first let's check to see that these two triangles are similar. So this one's a little bit different, right? We have a triangle inside of a bigger triangle. We have a smaller triangle, triangle RSV, is inside triangle RTU. Are these two triangles similar? Do we have a pair of congruent angles here? Okay, so what, Maria, what's one of the pairs of congruent angles that we have? Yeah, okay, so those two angles, they're even marked congruent for us, right? So that's good. All right, so that's one pair, but that's not enough, right? We need angle. We need two pairs of angles congruent. What other pair of congruent angles do we have here? So yeah, Evan, what do you say? Yeah, right. Angle R is held kind of like by both of the triangles there, so it's just congruent to itself, right? It's kind of like a reflexive, bless you, congruence. Okay? So yes, they are congruent by angle, and so again, we kind of have the similarity already written here, but there's our similarity right there. Triangle RST is similar to triangle RTU. Okay? So now let's set up here. We want to solve for RT, which is this length right there. We want to solve for that. Okay. So let's see here. So this X, and that's the length of RT. And so x, in the big triangle here, that's RT. Julia, what does RT correspond to in this smaller triangle? RS. So that means underneath the x we can put a what? 10. You got it. And then that's going to equal, and then what's another pair of corresponding pieces we can like match up there, Julia? Yeah, that's right. And so how should I write that? Should I put 12 over 8 or 8 over 12?
12 over 8.
Okay, how'd you know that was why we had to do it that way, 12 over 8?
Because the 12 is on the bigger triangle.
Yeah, so we did x, which is from the bigger triangle, over the 10, which is the smaller triangle. So we did 12 from the bigger over 8 from the smaller. That's right. Okay, and then we solve this by doing what, Julia? Cross multiplying. So we get 8x equals 120, and we divide both sides by 8, and we end up with 15. Okay, so there's the answer. Questions on any of that? Okay, cool. Well, so then let's do a little bit of reflecting here. So, in example 2a, is there another way we can set up the proportion to solve for BE than the way we did? So remember, in this one, we set it up as x over 54 equals 54 over 36. Is there another way we could have set up that proportion besides the way I wrote it? Is there a different way we could have set it up? There. Besides, again, I wrote x over 54 equals 54 over 36. Was there another way we could set that up? Did I have to do it that way? Is that the one single way to do it? So yeah, Hunter.
Could you just flip the fractions?
Yeah, exactly. Yeah, I could have. So we could. So instead of I had x over 54 equals what? 54 over what was it? 36. Yeah. Okay, 36. So we could have put, or maybe we could have had like the 54 over the x equals the 36 over the 54. Okay, those are also corresponding parts too, right? There's actually other ways to set these up, but I'm hesitant to show them to you just because I think these are the two best ways to set them up, because otherwise it can get kind of confusing. So I don't want to show those to you necessarily. We'll just stick with these right now. So either of those two. Okay. All right. Number 5 here says, when asked to solve for y, a student sets up the proportion as shown. So you can see here's our picture. Okay, and the student says y over 8 equals 14 over the 10. Okay, so explain why the proportion is wrong. So apparently this is not the right proportion. What is the mistake here? Why isn't this correct? And then we can maybe try and fix it. So, yeah, Mason, what do you say?
It should be 8 plus y over 8.
Okay, so why is y over 8 alone? Why is that not correct? What's the trouble there?
Because y is just the smaller part of the full size.
Right, so y is not a side of a triangle, whereas 14 is a full side, 10 is a full side, so 14 over 10, that's fine. But then comparing that to y alone is not the full side of the big triangle there. It's only just a little piece right here. So right, Mason's right. Okay, it should be y plus 8 over 8 equals then the 14 over 10. Okay, and you know how you want to explain why the proportion is wrong. You know, y over 8 is not a ratio of corresponding sides, right? Ugh. It's hard to write in when the book's all. So y over 8 is not a ratio of corresponding sides. Okay, y is not a side of a triangle. 8 is. 14 over 10, that's a ratio of corresponding sides, but y over 8, they're not corresponding. Okay, so that's why you don't match up. This is the correct way to write it right there. So good. All right, go ahead, try 6 and 7. Give those two a shot. All right, and I'll kind of come around and help as needed. But go ahead and give 6 and 7 a try.
sure you're matching up corresponding parts. Corresponding parts. So, yeah, so we know they're going to be similar, right? Now it's a matter of then finding the differences in A and B. So we set up this way on that X. Now, how would you provide your ratios now? So remember, your ratios always need to be ratios of corresponding sides. So pick a side that you know. Okay, 80 is 6, right? What other side does AB correspond to? Bigger. AD. And if you look up here, you need to, here's your similarity table, right? So there's AD. What must it correspond to? AD. Aha! What's the number of AD? X, right? So it's going to be 6 over X. That's the first ratio. And that has to equal. What's another ratio you can come up with? Okay, so be careful. You said 6 on this triangle over X. It's bigger. So pretty equals 15 over 9. You switch it up. That's right. You did smaller over bigger, so you do smaller over bigger. Okay.
Anyone else having any troubles, questions, comments? Yeah, Keegan.
Should I format the same as this?
It's going to be kind of similar. So again, you want to find this, right? So why don't you call that right there, we'll call that X, yeah? Okay, so now match up corresponding parts. So for example, in this smaller triangle here, right, you got a 9, for example, for that measure. What does this correspond to in this triangle right here? What is the 9, what side does 9 correspond to in this triangle?
Same thing.
So it doesn't. Yeah, I was going to say, yeah, be careful how you're looking at it there.
This one?
Yes, so you can put 9 over 12.
Or 12 over 9?
Or 12 over 9, yeah, that's fine. Equals. And then what the only other side of this big triangle that you have is this, right? What's the expression for this side? Go ahead.
X plus 9.
That's it, yeah, uh-huh.
Awesome.
Over.
15.
Yep, and that's it. Cross multiply and solve. Good job.
Yeah, okay.
2 more minutes here. We're finishing up. Okay, so let's see here. So 9, okay, is it's like the part of this right triangle, right? It's kind of like this side. So what should that correspond to then in the bigger triangle? 12, right? Okay, so 9 over 12, and then, yeah. So let's see here. So now we have this side and the smaller triangle, the 15, so that can go on top of the other ratio, right? But then what side does that correspond to? 9 plus x. There you go. Okay, how's the Chelsea's square on the floor? Oh, you think it's similar? So what makes you say that? They're not the same orientation. So look at the 2 triangles. You have a right angle and a right angle, and then these 2 angles are congruent too. So by the angle similarity, the 2 triangles have to be similar. So you can set some ratios here. So make sure, but here's the trick, you gotta make sure you're matching up corresponding parts. So one thing that might be helpful is if you actually like write the triangle similarity statement out. So for example, let's name this triangle TSQ. Now that's going to be similar to how we name the other triangle. So yeah, we have T with the P, right? And S and S, yeah. Okay, so for example here, and we want to find PQ. Alright, so PQ, you're right, it's not in a ratio with any of these sides here, but it's not the side of the triangle. It's like part of the side. What is this whole side of the x? How can you describe it? What expression would you write? Yeah, so I'll let you write that one out. So x plus 9. And then what must PF match up with over here? Yeah, so it's x plus 9 over 15. And then you can find the next one, right? Okay. All right.
Oh no, I gotta take attendance. Probably logged me out. It did log me out. Awesome. Alright, so let's see what we came up with here. So I'm going to go to Patrick for number 6. What was the ratio you came up with there?
3 over 5.
So 3 over 5. Oh, you simplified it ahead of time?
Well, I started out by writing out 6 over AB equals 9 over 15.
Okay, yeah, so AB, right, and that's the unknown measure. I'll call that X. So I'm going to call it 6 over X, and you said equals 9 over 15. Good. And then you simplified that 9/15?
Yeah, to 3/5.
Okay, to 3/5, so then we can say that 6 over X equals 3/5. That makes it a little bit easier with the multiplication and stuff. And then what'd you do to solve here? Or actually, I guess you don't really need to do... Well, go ahead, sorry, I want to interrupt.
6 divided by 3 is 2, so that has to be 5 times 2, which is 10.
So yeah, to get from 3 to 6, this direction, right, we multiply by 2, so 5 times 2, X has to be 10. So that's one way to think about it. Yep, you also could have cross-multiplied there and solved, but that works too. So X is 10. Okay, which is then AB, right? AB is X, so that's 10. All right, great job, Patrick. Thank you, sir. All right, let's go to Michael. How about you, Michael, for number 7? We want to find PQ here. Actually, I forgot to ask. Number 6, we kind of assumed the 2 triangles were similar, right? We weren't really told they were similar. They might not have been similar, and if they're not similar, then we can't solve, but we know they're similar because, well, how do we know these 2 triangles are similar? And number 6, let me go back to number 6 here. How do we know these 2 triangles are similar? How do we know they're similar? Because it says to explain how he knows that triangle AED is similar to triangle ACB. Yeah, Hunter. What would you say?
Two corresponding angles.
Okay, so yeah, we got parallel lines. Here crossed by a transversal, so that means this angle and this angle are going to be corresponding, so they must be congruent, and same deal there. And of course, A is shared by both of them, so really all three angles were guaranteed to be congruent with that. So yeah, they're similar by angle. Okay. If you didn't write that part down, I'm not too worried about it. That was, we kind of like, yes, you can't do the problem if it's not similar. Okay. I will say in the homework, though, there will be some problems that are not similar, and so then you don't have to do them. You just stop and you say not possible, So just keep that in mind. All right, Michael, back to you then. Sorry for the wait. Number 7, how would you set this one up?
I did 9 plus x over 15 equals 12 over 9.
Okay, that sounds good. 9 plus x over 15 equals 12 over 9. Questions on that setup there? Yes. Just not sure how he got it? You just got x over 15. So here's the thing. This 15, right, is the full length of this one side of the small triangle, right? It's like TS, the full length, right? So what does that match up with? If we just say x, is that the full side of the other triangle? See what I'm saying? PQ is that little measure right there, right? So that's not the full side length. That's not what we want. We need to do the full side length here, which would then be the x plus the 9. That's why you have to add those pieces together, okay? And then when we do that, you cross multiply and solve here, so let's see, we get 81 plus 9x equals 180. And we can subtract 81 from both sides, you get 9x equals 99, and so x equals 11. So PQ is 11. Is that what you got there, Michael? Rock and roll. Okay? Questions on any of those then? All good? All right, so moving on then, we got some other triangle similarity theorems, okay? Side, and side, angle, side. All right, so in addition to angle, triangle similarity, we have these two, side, and side, angle, side. All right, side, to determine if two triangles are similar by side, then we need three sides of one triangle to be proportional to the corresponding sides of the other triangle. Okay, and for side, angle, side similarity, we need if two sides of one triangle are proportional to the corresponding sides and their included angles are congruent, then the triangles are similar. Okay, so we also have these. All right, so letter A up here, we want to determine whether the triangles are similar and then justify our answers. All right, so we can see here we can't use angle. All right, all we have is one pair of congruent angles here. So we can't use angle. We don't know enough information about these other parts to really say that they're going to be similar by angle. So we have to either use side, angle, side, or side here. All right. So which one does it look like we're going to be using? Side, angle, side, or side? Side, angle, side. Elizabeth, why do you say that? Right, exactly. And so it also can't be side because we don't have the third pair of sides there even we don't have any measures for that. So it can't be side. We don't have enough information to do it with side. And so we have to determine, okay, we have a pair of congruent angles, so let's see if we can get these sides to match up. So Elizabeth, MN here, for example, what does that correspond to in the other triangle? MR. So we could write what ratio then? Sure, 4 over 6. That must equal, and then what's another corresponding pair of parts? So MN, let's see, the only other side in this smaller triangle that we have is MP. So Evan, what would be another ratio we could write there?
Well, if you add 84, that's 12, that's the big one for MQ.
Okay. So what would be the ratio over here I write?
8 over 12.
8 over 12, good. Yeah, 8, because 8's from the smaller triangle, just like the 4 was, over the 12, which is from the larger triangle there. And so we want to know, are these two things equal? Okay. Are they equal? So how do we know if they're equal here, Evan? What do we do? How can we determine if they're equal or not? Okay, we can cross multiply. That's one way to do it. 4 times 12 is 48. 6 times 8 is 48. So are they equal?
Yes.
Yeah, they're equal. Okay? So, triangle, let's see here, we got to name this carefully. Well, the first one we can name however we want. So I'll name it triangle MNP is similar to, and then Lindsay, since I named this first triangle MNP, how do I have to name that second triangle? Very good. Again, making sure we get those corresponding parts to match up. By, side, angle, side. Okay? All right, let's skip on down here to B. All right, so let's see here. Lindsay, what kind of similarity are we going to maybe shoot for here? Do we want to use angle, angle, side, or side, side, side? Probably side, 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 right? You got it. All right. So let's go to Mason. Can you set up some of our ratios here? What does it look like is going to be corresponding?
ML and GH, so you could do 8 over 12.
8 over 12, okay. And we want to know, is that equal to, what's another pair?
10 over 15.
10 over 15. And is that equal to what other pair?
4 over 6.
4 over 6, okay. Remember, guys, we have to check all three pairs, okay? If just one of those ratios is different from the other two, it is not similar. But in this case, all of these are similar, right? Another way you can do this is just do the division here. 8 divided by 12, okay, it's 2/3, or you can just simplify the fractions. 10/15 is also 2/3, and then 4/6 is also 2/3. So check. These things are similar. So we can say triangle, GHJ is similar. Let's see here. Tanner, how would we name the second triangle there? So I said GHJ for this one. What would the second triangle have to be then? L, yep. And I went from G to H, so that means I have to go from L to M. And then the last one obviously must be N, by process of elimination. Okay. So there's that. All right, by, side, side, side. Okay. All right, I do kind of want to look at these two questions down here at the bottom. So, number 8 says, are all isosceles right triangles similar? Why or why not? So I think what they're trying to say here is if you have one isosceles right triangle and another isosceles right triangle, must those two be similar? Must any two isosceles right triangles be similar? And then why or why not? So what do you guys think there? Must any two isosceles right triangles be similar to one another? What do we think here? So Drew, what do you say?
Yeah, because it has two sides that are congruent in one angle.
Okay. So an isosceles triangle, right, by definition, and it's going to be a right isosceles, that means it's going to be like this right there, and then the two, I didn't do a very good job drawing that. We have the angles will be congruent. I'll draw another one, I guess. Okay, something like that. And so since these two angles are going to be congruent, oh my goodness. Sorry about that. There we go. Since these two angles will be congruent, and these two sides will be not necessarily congruent, but whatever the side ratio here is, the side ratio here will be the same as those two side ratios. So yeah, the answer is yes. All isosceles right triangles must be similar. Yes, by side, angle, side. Okay? And you can say, I don't know, they both have a 90-degree angle. Bless you. And the legs will be in the same proportion. Will be proportional. Okay. So that guarantees that these two triangles will be similar. Again, we have two pairs of congruent here, and those will be in the same ratio or the same proportion as these two as well. Whatever that ratio might be. The ratio, obviously will be different for different triangles, but they will always be in the same ratio there. So yeah, guaranteed to be similar. It's pretty interesting. Okay. And then number 9, why isn't angle side angle? Remember, angle side angle is a congruence. Why isn't it a similarity? Why didn't I talk about angle side angle similarity here? So again, we talked about angle similarity. We talked about side similarity. We talked about side similarity. But why isn't angle side angle? Or really, for that matter, we also don't have angle side too. Why is it?
Because they only have one side.
They only have one side. That's true. Mm-hmm. What else do they have though? They have one pair of sides. They have one pair of sides. What else do they have? Two angles. But what's the similarity theorem that has two angles? What's the similarity relationship that we already have? Angle, right? Angle side angle and angle side, they're already angle similarity. They're already going to be similar by angle because both of these things have two angles already. All right? So both relationships have two congruent angles already. So they will be similar by angle. Okay? There's no need for we don't care about the side. I mean, yeah, I guess the sides are there, but it doesn't matter. Since we already have two angles in both of those, the triangles must be similar already. All right. So rather than have you guys do your turn on the next page, I'm going to go ahead and just give you guys the assignment. That way we can get started on the homework instead, and that way, you won't have as much tonight to do. All right. So there's that. Your assignment will be starting on page 617. I would like you to do. Let's see here. So 617, numbers 3 through 15, and number 18 as well. Okay, so 3 through 15, and then number 18 as well. I'm going to give you a little bit of a hint here for number 18. Okay, you'll notice that your units are mixed up here. So for example, we have a measurement of 15 inches, but here we have measurements of like feet and inches. So what might be helpful when you're going to go work on this problem? What might be helpful for you here to do with these numbers? Any ideas here? Yeah, Mary? Yes, I'd recommend you convert the feet and inches and the feet and inches here all into just inches, so that will help you, get those answers right. So again, it's 4 through 15 and 18 as well. 3 through 15 and 18 as well. Okay. Please make sure you check to see if the two triangles are similar. I will tell you right now, I know of at least 2 triangles in this assignment that are not similar, and you won't need to then work any further, okay? So once you realize the triangles are not similar, you may stop and say, not possible, okay? So please do check that first.